Hey everyone, so today we're going to be working on our Unit 1 video for AP Calculus, evaluating limits graphically. So last year in pre-calculus you guys did do some limits. We'll treat this as though, it's new for everyone or just a really heavy review of that. So first we're just going to start with evaluating some y values. Remember, when we ask for f of -4 or f of 0, we're just looking for that y value. So let's take a look at f of -4. We scan over to -4 and we say the y value there is -1. So that's what we're going to go through and do here, just evaluate those points. So f of 0, we go to x equals 0, we kind of scan up and down. We notice that there's both a closed circle and an open circle. Remember that the value is that closed circle, so f of 0 is equal to 1. All right, and then f of 1, we take a look here. F of 1 looks like it's about between 1 and 2, but if you actually look at the slope of this line, the slope of this line is 3/2, up 3 over 2. So we can actually figure out that this point is right at, let's see, we're going up 1 over 2/3. So that would be at 1 and 2/3. Okay, and then finally here, how about f of 2? F of 2, we notice, we kind of scan up and down, and we see that open circle there. That value does not exist, so that's going to be undefined. And f of 4, this might look familiar to you guys. F of 4, there's this dashed line. It's called a vertical asymptote, and at that asymptote, we don't have a value. Our graph approaches it but does not cross it, so same thing here, f of 4 would be undefined. Okay, so as you guys might remember, for limits may differ from the y value. So what we're going to do is just take a look, same graph here, do some limits from the left and from the right. Okay, and we're going to write this with our new calculus notation that you might have seen before. So let's take a look first at what's happening at -4. Okay, so I'll start off with from the left. So as we scan from the left, this graph, as we're getting closer and closer to -4, what y value am I approaching? I'm approaching -1. And we write that as the limit as x approaches -4 from the left. So we're going to have that little negative sign up there of f of x. The limit of f of x as x approaches -4 from the left, that's how we would say that, is equal to -1. Okay, and what about from the right? Well, from the right, I'll use orange here, getting closer and closer and closer to -4. That is also approaching -1. So the limit as f of x, the limit of f of x as x approaches -4 from the right. So notice that little plus sign, that means from the right. That's also equal to -1. Okay, and we're going to be talking about this left hand and right hand limits shortly. Right now we'll just say from the left and from the right. Okay, let's try a couple more here. How about, I'll go back to pink here for this left limit. What about as we approach 0? So as you come to 0 from the left, so scanning our graph, boom, we end right there at, where am I at? +1. That y value, again, where am I approaching? I'm approaching 1. So the limit as x approaches 0 of f of x from the left, sorry, should be a little negative there. I don't know if you can see that. From the left is 1. Okay, but if I take my function and look from the right, I'm scanning with my orange pen here. I actually end up the limit, the y values are getting really, really close to 3. I don't really care if there's an open circle there. What I'm looking at is what are my y values approaching. As I get closer to 0, I'm at 2.5, 2.6, 2.7, 2.999, really, really close to 3. So the limit as x approaches 0 from the right, f of x is approaching 3. Okay, so let's take a look at when we're approaching 2. Okay, as x approaches 2. So we notice, guys, first of all, there's this hole at 2.2, 0.15. So this y value that hole there is 0.15. So that's where I'm going to be getting these numbers from. Let's take a look then. So as we get closer and closer from the left, I'll go back to pink here, sorry. So as I approach 2 from the left, getting really close, really close, really close to that 0.15. The limit as x approaches 2 from the left of f of x is 0.15. And then again, I'll go orange for right. As I come from the right side of the function, getting closer to x equals 2, I'm getting really, really close to that y value of 0.15. Okay, and if that hole wasn't given, I think you could probably say 0, but since we know it's at 0.15, we're going to use that information. The limit as x approaches 2 from the right of f of x is 0.15. Okay, and we're going to finish this up. What about as we approach 4? Okay, this is kind of a tricky one. So I'm going to take pink again to come from the left. I'm going to erase some of this color I have here. Okay, as I come from the left, okay, as I get closer and closer to 4, what's happening to my y values? I'm at 4, I'm at 6, I'm at 100, I'm at 1,000, right? This is going towards positive infinity as I come from the left. Similarly, in this case, as I go towards that asymptote, from, I go to 5, I'm at 4.5, 4.2, I'm getting really close to that x value of 4, and my y values just keep increasing. I'm going to continue towards positive infinity. So in this case, and we're going to be talking about vertical asymptotes a lot more in this class, but that is one significant point for vertical asymptotes, is that our limits are going to approach infinity or negative infinity as we get closer to that asymptote. So let's jot these down here, guys. The limit as x approaches 4 from the right of f of x is infinity. I'll switch colors here. The limit as x approaches 4 from the left is also infinity. Okay, so take a second. Remember, the beauty of a video is you can pause whenever you need to, so feel free to pause if you need to continue writing. Okay, so we're going to move on to some notation. I wrote this down for you here, and we've already been talking about these two. Okay, from the right hand limit, so if you're scanning from the right, okay, we've got that little baby plus sign above our value. C is just some arbitrary value here. And if we have that little negative, that just means from the left, okay? If there is no negative or positive, that just means the limit in general. Okay, so when is the limit in general existing? When do we have a limit? What if I just asked you, what's the limit as x approaches 2 in general? Okay, that limit exists only if the right-hand limit, okay, is equal to the left-hand limit. And this is in a kind of different format here. So the limit exists if and only if the limit from the left is equal to the limit from the right. Okay, so let's see what that actually looks like here. So when does our limit exist? Because we might have a left-hand limit and a right-hand limit that both exist, but overall they do not. So let's actually scan back up here and kind of check this out. So what if I asked you, take these 2 points, this was for -4. Okay, what if I asked you in general, what happens as we approach -4 for f of x? Okay, well, if from the left I approach -1, and from the right I approach -1, overall, the limit as we approach -4 is -1. So that limit does exist. Let's take a look at the next one here. What about as we approach 0? You're already going to notice these two values are an issue. As I get closer to 0, well, from this way I approached 1. From the right I approached 3. So the limit as x approaches 0 of f of x does not exist. And we'll use that DNE for does not exist. Again, because that left-hand and right-hand limit are not equal, these two numbers must be the same for that overall limit to exist. Okay, and if you take a look, the next two, looks like we're smooth sailing from here. For as x approaches 2, okay, what do we know? Well, as x approaches 2 in general, since from the left I approached 0.15 and from the right I approached 0.15, the limit in general is 0.15. I want to reflect back on when we asked what f of 2 was. So notice f of 2 did not exist because it was that open hole, but we can have a limit even if there's not a function value there. So that was why I mentioned y values may be different than their limit at that x value. So just as a heads up there, we might have a limit even though there is that open circle. As long as the y, we don't really care what the value is, it's what those y values are approaching. Okay, and last but not least, what about if we talk about I approach 4 from either side? In both of those cases, I approached positive infinity. So that limit exists. Okay, so we're gonna actually just take a look. If you guys scan down here, we're gonna just look at one more example. And again, here's your definition. This will come up, so make sure you know it well. Left-hand limit has to be equal to the right-hand limit for that overall limit to exist. Okay, so here's what we're going to look at, and then we'll finish this second piece in class. So here's our graph f of x, okay? And we're just going to run through some right-hand limits, some left-hand limits, maybe just a limit in general, all right? So how about as we approach 1 from the right? So as we get closer to 1 from the right, again, take your right hand, scan towards that value of x equals 1. We're getting closer to the y value of 1. Okay, and it's actually constant, so it's just 1 between there. Okay, what about from the left? As I get closer to 1, so scan with your function, your left hand here. As I get closer to 1, I'm actually getting closer to the y value of 0. Okay, and we'll notice these are disconnected. So if my right-hand limit is 1 and my left-hand limit is 0, what happens as x approaches 1 in general? This would be a does not exist. Again, because left-hand and right-hand limits were not the same. These were not equal to each other. Okay, and just to flash back, again, what about if I just ask f of 1? F of 1, again, is looking for that closed circle, that function value. In this case, what happens at 1? F of 1 is 1. All right, let's take a look at, how about if we approach 2, x equals 2. So 2 from the right, what's going on? As we approach from the right, we're getting really close to that value of 1. Okay, as we approach from the left, we're getting close to a y value of 1. So we notice the left-hand and right-hand limits are equal. And in general, if those are equal, then we know x approaching 2 in general. We can also say that is equal to 1, since both the left-hand and right-hand limits were equivalent. And last but not least, what about f of 2? Well, if I scan here, where is that function value? It's actually at y equals 2, so be careful here. It doesn't necessarily have to equal what the limit is. All right, and one more row here, I'll do it in pink. We'll talk about x approaching 3. Okay, so x approaches 3. From the left, I'll use pink, getting close to that y value of 2. From the right, oh, I'm so sorry. That was supposed to be from the right. Well, luckily it doesn't matter in this case. Oh, yeah, 2. And then from the right, I'm approaching 2. Sorry if I messed that up the previous time. From the right is this way, from the left is this way. Both approaching 2, meaning overall, we can say the limit as x approaches 3 is 2. And last but not least, f of 3 is 2. Okay, we're going to be talking about that word continuity. Continuous, you might have heard this before, and we are continuous at this point. Again, that more to come on that. The last one I wanted to throw at you is what about if x approaches 0? You'll notice that we have no clue what's going on from the left over here. You know that from the right it approaches 1, okay, but the left we don't know. This is kind of a special situation. If we don't have any information on the graph that we know the left behavior, we can just assume from the right that it's going to be x equals, or excuse me, a function value, a limit of 1. So again, just wanted to clarify that since it is kind of a special case. All right, guys. Well, thank you so much for watching. Again, we'll finish this bottom half in class, and please email me or leave any questions on Edpuzzle. Thank you.